Hey, welcome back. Today we're going to talk about applications with Trig. The first two examples I've actually filled out for you, and you'll be able to find these on our class notes from before we left for break. We did these exact two examples, so you can refer back to the copy of my class notes that I put on the classroom. Just a reminder, we're using trigonometry, so the sine, the cosine, and the tangent of our acute angles and our right triangles to help us find either side length or angle measure. In the first one, we're looking for side length, so we would use regular trig. In the second example, we're looking for angle measure, so that's where we're going to use the inverse trig. So let's just do a quick recap. In example number 3, it says the sides of a rectangle are 32 centimeters and 20 centimeters. So let's draw our picture. 32 centimeters and 20 centimeters. And we know that a rectangle has 4 right angles. What is the measure of the angle formed by the short side and the diagonal? So I have to draw in my diagonal here. And I want to find the angle measure created by the short side and the diagonal. So that's this angle right here. So let's call that x. We're looking for angle measure, so therefore we're going to use inverse trig. So this is my hypotenuse, this is my opposite side, this is my adjacent side. We're comparing the opposite and the adjacent. So when we compare the opposite and the adjacent, we are using the tangent ratio. So we're going to take the tangent of angle x and set that equal to the opposite, which is 32, over the adjacent, which is 20. And now we'll do the tan inverse. And just on your calculators, we like the inverse because this is just tan inverse 32 divided by 20. And that leaves us with about 57.99 degrees. So this is about 58 degrees. So the angle that the short side and the diagonal make is 58 degrees. The next question uses some language that we're going to talk about in this video today. It says a flagpole casts a shadow 40 feet long when the angle of elevation to the sun, so this is new terminology, is 31 degrees. How tall is the flagpole to the nearest tenth of a foot? So when we think of elevation, that means we're going up. So on the next page, we're going to define two different types of angles. We're going to have the angle of elevation, and we're going to have the angle of depression. So here we have our notes on the angle of elevation and the angle of depression. So an angle of elevation is formed by a horizontal line and the line of sight to a point above that line. So if I'm standing here, and this is my line of sight, and I look up to see this plane, that angle that's created is my angle of elevation. So I'm going from a line of sight and I'm going up. Now sometimes that line of sight can be on the ground, so from the ground to the top of a tree, from the ground to the top of a flagpole, ground to the top of a cliff. That can also be an angle of elevation. So it starts at the horizontal and goes up. The angle of depression usually starts in the sky somewhere. So it's your line of sight, so look straight ahead and then look down to an object on the ground. You've now created that angle of depression. So from that line of sight going down is that angle of depression. From that line of sight going up is that angle of elevation. So let's use these two definitions and fill in the angle of either depression or elevation for these 4 examples. So example number 1, angle 1. Is it an angle of elevation or an angle of depression? Here's my line of sight, that dotted line. I'm going up. This is my angle of elevation. Take a look at angle 2. Here's my line of sight again, but now I'm going down. This is an angle of depression. What about example number 3? Good. That would be an angle of elevation. And what about example number 4? Good. That's going to be an angle of depression. So now let's go back to our previous example where we have the flagpole. So here we have a flagpole that casts a shadow 40 feet long with an angle of elevation to the sun is 31 degrees. So let's draw our little flagpole here. Here's the ground. This is our shadow. Shadows are always on the ground. Here's our flagpole. And then we have some sort of point on the ground where our angle of elevation is. So our angle of elevation is happening from the ground up. It tells us that that angle of elevation to the sun is 31 degrees. So if I have a 40-foot long shadow, and I want to know how tall the flagpole is, what trig ratio are we going to use? Good. It's going to be the tangent ratio. So we'll take the tangent of 31 degrees and set that equal to x over 40. And I'll let you solve that equation for x. And hopefully you got a height of the flagpole equaling 24 feet. All right, so now let's take a look at this next question. It's another angle of elevation question, very similar to the one that we just did. So I'll set it up for you and then you can finish it later on. The angle of elevation from point A on the ground to the top of a cliff is 38 degrees. Notice how I labeled everything. This is really important. 38 degrees. If point A is 80 feet from the bottom, so we're talking horizontal distance, how high is the cliff? So the cliff is my vertical distance. The ground, the distance from point A to the cliff, is my horizontal distance. Then I have some sort of angle, either angle of elevation or angle of depression. And then I have my hypotenuse, which is that diagonal distance. That would be like a kite string or something like that. And I will let you solve that for x. All right, now let's do an angle of depression question. So angle of depression, remember, starts from some horizontal line of sight and goes down. So this is my angle of depression here. From the top of the tower, the angle of depression to a point on the ground is 72 degrees. So this angle right here is 72 degrees. The top of the tower is 80 feet above ground. Remember we talked just previously about our vertical distance versus our horizontal distance. How far is the point on the ground from the bottom of the tower? I want to figure out this value of x. Now notice there's a problem here. Our 72 degrees is not inside our triangle. So here's a rule of thumb that we use. Our line of sight, this dotted line here, and the ground are parallel to one another. So if we have parallel lines cut by a transversal, what is the measure of this highlighted angle in here? That's right. It's 72 degrees because alternate interior angles are congruent. And now we can use this to solve for x. This is my opposite side, this is my adjacent side, and this becomes the tangent ratio. The tangent of 72 degrees equals 80 over x. Here, I'm going to switch. This becomes x equals 80 divided by the tangent of 72 degrees. And then we can solve that for the horizontal distance on the ground. And you should get approximately 26 feet. All right, let's take a moment to just set up these last two examples here. One is an angle of elevation, the other is an angle of depression. So for question number 7, when the angle of elevation to the sun is 37 degrees, a flagpole casts a shadow that's 24.2 feet long. What is the height of the flagpole? So again, the shadow lives on the ground. This is our flagpole. Here's our sun. We're talking angle of elevation, so that means from the ground up. Our shadow is 24.2 feet. And we want to know what the height of the flagpole is. So angle of elevation from the ground up. Label the shadow on the ground, the height of the flagpole, and then we can use our trig ratio to solve. And hopefully you have the tangent ratio. All right, last example we'll do together. A forest ranger in a 120-foot observation tower, so that means the tower is 120 feet tall, that's our vertical distance, sees a fire. The angle of depression to the fire is 3.5 degrees. So remember, your angle of depression starts from your line of sight and goes down. What is the horizontal distance between the tower and the fire? Our tower is 120 feet. Now remember, this 3.5 degrees is outside of my triangle right now, so I'm going to use the alternate interior angle. And I know that that angle inside my triangle is also 3.5 degrees because our line of sight and our ground are parallel. And now, create an equation to solve for that horizontal distance on the ground. Hopefully you used the tangent ratio and solved that in order to get that horizontal distance on the ground. And just so that you have them, the answer to number 7 should be approximately 18.2 feet. That's how tall your flagpole is. And the answer to this one is approximately 1,962 feet away. And that's it. Have a great day. See ya.